welcome to Csc102 Study Section 4, and this is going to be the second part of the class. We are going to be talking about overview of programming, then we talk about the types of programming languages in this part. So let's go on. Last class we've been introduced to the overview of programming languages, and that was where we talked about why the need for intermediate language. We're told that since human beings cannot speak or write in computer language, we need an intermediate language that can be able to communicate with computer, and that was why we have programming languages, which will allow a computer programmer to direct the activities of the computer. Then we moved on to talk about operation codes, which can also be opcodes, and these are what tell the computer what to do, such as add, subtract, multiply, divide. Then we also have operands. Operand will tell the computer the data items that are involved in the operation. All these have been talked about in the last class. Then we also gave us an example where we have A equals B plus 2, and we're told that the operation codes are equals to and plus. Then we were also told about the operands, that A, B, and 2 are the operands. So that A and B can be storage devices, while 2 are storage devices, while 2 is the actual data in the memory. So we've talked about all this in our last class. Then today we are going to move on to instruction. We are told that instructions are being housed in computer system. We have instructions. We have different forms of instruction. We have the input instruction, the input-output instruction. We have the arithmetic instruction. We have the branching instruction. We have the logic instruction. Now let's take these instructions one by one. When we say input instruction, the input instruction is the one that directs the computer to accept data and store it in a specific location, to accept data and to store that data into a specific location. That is the input instruction. Then we have the output instruction. The output instruction will tell the computer to move a piece of data from a computer storage location, and it will record it into an output medium. So what the output instruction will do is that it will tell a computer to move a piece of data, particular data from a computer storage location, and to record it to an output medium. That is output instruction. Then we also have the branching instruction. Before I go to the branching instruction, the arithmetic instruction is just like we have in our arithmetics. We can have add, subtract, divide, multiply. So these are the instructions for the arithmetic instruction. Then for the branching instruction, this causes the computer to alter the execution of the instruction within the program. It will make the computer to alter, to change the execution of the instruction within a program. That is the branching instruction. And under the branching instruction, we can have the conditional branching instruction, and we can also have the unconditional branching instruction. Don't forget that I said the branching instruction will change or say it will alter the execution of instruction within the program. Now let's take the different types we have one by one. We talked about the conditional branching instruction. The conditional branching instruction will cause the computer to branch to a statement only when certain conditions exist. That's why we say it is conditional branching instruction. It will cause the computer to branch to a statement only when certain conditions are met. That is when it will alter the execution of that instruction. Then we have the unconditional instruction. The unconditional will cause the computer to branch to a statement regardless of the existing condition. It will branch to a particular statement regardless of the existing condition, regardless of the condition that has been stated before. And that is why that is unconditional instruction. So under branching instruction, we have unconditional and conditional instruction. Then now let's move on to logic instruction. Logic instruction will allow the computer to change the sequence of instruction of execution of instruction. It will change the sequence of execution of instruction. depending on conditions that are being built into the program by the programmer. This depends on the condition that has been built into the program by the programmer. So what logic instruction will just do is to change the sequence of execution of instruction. So these are the forms of instruction that we have: the input output instruction, the arithmetic instruction, branching instruction, the logic, and the logic instruction. So now let's go to programming language. What do we mean by programming language? We have told us that programming language actually was created because human beings needed to speak to the computer, and we don't use our own mother language to speak to the computer. We need what we call programming language. So that's why we say programming language is a formal language consisting of sets of instructions and rules. Consists of instruction and rules that allows humans to communicate with computer. And we can also say that programming language provide a way to write algorithm and instruction to perform specific tasks or solve problems. Don't forget that the computer is meant to solve a particular task, or it's meant to solve a particular problem, and we need a particular language in which we can be able to communicate with this computer so that it will be able to solve this problem. And that is why we say programming language provides a way to write algorithms. Algorithm are a sequence of instructions that we write to solve a problem. So it provides a way to write algorithm and instruction to perform specific tasks or solve problems. Now let's go to different categories of programming language that we have. We have different categories of programming language. We have what we call the low level language, and we have the high level language. Although this is not in your scope of work for now, by the time you get to higher level, you'll be talking about this very well. Let me just review about it before I go to what is in your own scope of knowledge for now. So we have what we call low level language, we have high level language. And under the low level language, we have the machine language and we have the assembly language. So these two are actually under the low level language, and we have the high level language. And under high level language is where we have the high level language and we have the very high level language. So take note, you will still see later on as you move higher that the broad category of programming language that we have are the low level language and the high level language. And it is now under the low level language that we have machine language and the assembly language. These are low level languages. And under high level language, we have high level language, very high level language. So for your level now, under the categories of programming language, we have machine language, assembly language, high level language, very high level language. So now we are going to be taking them one by one. Now let's talk about the machine language. Machine language are built in binary number system. And this is the language that the computer understands. What we say binary number system, meaning they are written in zeros and one. Machine language are the language that are written in zeros and one. They are written in zeros and one, which is the language that the computer system understands. And but one thing about machine language is that it is difficult, time consuming, and prone to error. Difficult because they are written in zeros and ones. So to learn them, it's a little bit difficult, and it consumes time because you have to be writing zeros and ones for the program you want to write, and you can easily make mistakes with this. That's why we say they are prone to error or mistake. So then, for another thing about machine language is that it does not need a translator. Why do we say it does not need a translator? It doesn't need a translator because this is actually the language that the computer understands. So since it's already been written in the language the computer understands, you don't need to translate it into any other language. So that is why we say machine language does not need a translator. Now let's move on to assembly language. Assembly language. Assembly language is also a type of low-level language. It's also a type of low-level language. And for this assembly language, it involves use of symbolic codes. That's why we say it uses symbolic method of representing instructions. It uses Assembly language uses symbols. It uses symbols. These symbols, we call them mnemonics. It uses mnemonics. It brings up. It's just like you when you were in secondary school, when you have to cram the 20 elements. You can have the first letter or the first element, then they take the second element, the first letter. Then when you put it together, it forms what we call mnemonics. So the same way, that is what assembly language, instead of the zeros and ones that are being used, it involves using combination of letters that are known as mnemonics to represent the operation codes. So it uses combination of letters, and we call these mnemonics. That's why we said it uses mnemonics. So assembly language uses mnemonics. And it was created because machine language is time consuming. Assembly language was created because machine language is time consuming. Then it needs a translator because it's not written in the language that the computer understands. We need a translator for this. And the translator that is being used is a software called, it's a system software program called assembler. So for the assembly language, you need a translator to translate it back to that language that the computer understands. And that system software program that we use is called assembler. Then another thing about assembly language is that assembly language is machine dependent. It depends on the machine in which it is the language the program is being written. You cannot run it on another machine. If it is being written in IBM machine, it will only work on the IBM machine. That is why we say it is machine dependent. That is assembly language program. Then we also have high level language. High level language. High level language. But before we move to the high level language, there's one more thing I want to say about the assembly language. Assembly language is typical since it requires the programmers to create programs based on specific computer operation codes. Assembly language is difficult since it requires the programmers to create programs based on specific computer operation codes, and you have to combine the letters and you have to combine letters to make what we call mnemonics. So that is why we say assembly language is difficult. Then now let's move on to high level language. High level language was actually created because assembly language and machine language are difficult and time consuming. The two languages, the two low level languages are difficult and they are time consuming, and that is why the high level language was created. So this is a little bit easier because it uses English words. It involves assembly language can be written with particular sets of numbers, letters, and you can use special characters, and precise punctuation rules must also be followed for assembly language. So this is easier than the machine language and the assembly language. And high level language rather are machine independent. That means it can run on any machine. It does not say, okay, this is because you wrote this language, the program for a particular machine, that you cannot transfer it to another type of machine. So it is machine independent. Assembly high level language is machine independent. It doesn't depend on the language or the program on the machine that has been written. So it can be used on any machine. Examples of high level language and Fortran, we have the basic, COBOL, Pascal, ADA. So these are examples of high level language. And for high level language, we need what we call a compiler. What is the function of a compiler? A compiler is needed to convert the high level language to machine language. Don't forget, for machine language, we mentioned that for machine language that they are written in binary number system. They are written in zeros and ones, which is the language that the computer understands. So you don't need any translator for that. But for the assembly language, you need what we call the assembler to convert it to machine language. So for high level language now, high level language needs a compiler. or an interpreter that will have to convert the high-level language back to machine language, which is a language the computer understands. So these are the different categories of programming language that we have. Then we also have the very high-level symbolic language. So we have machine language, assembly language, high-level symbolic language, very high-level symbolic language. So we are going to start with overview of programming languages here. And in our next class, we'll be moving to study section 5, where we are going to take a particular program. The program we are going to start with is the basic beginners all-purpose symbolic instruction code. So that is what we are going to go to in our next class. So we'll be going to the study section 5, which is the last study section. Thank you.